Well, hi, this is Dr. Thomas, and you've been waiting for this session on the elimination method, so here we go. Let's talk about elimination using addition. So if you were looking at this system right here, you have x minus 2y equals 5, and you have 2x plus 2y equals 7. We want to eliminate one of these variables because right now you can't solve for a variable because you have two variables in each equation. But if somehow you can combine these equations and only be left with one variable, you can just solve for that one variable. Now notice that you have a negative 2y and a positive 2y here. So if we added these two equations together, then the y term will eliminate. Okay? So let's add both equations to each other. If we do that, the negative 2y plus 2y will cancel. And this x plus 2x is 3x, of course, since x is 1x plus 2x. Of course, we have an equal to sign, and 5 plus 7 is 12. Now we only have to solve for x. How do we solve for x here when you have 3x equals 12? You just divide by 3 on both sides. You get x equals 4. So we know part of our answer. Our answer for x equals 4. But we want to know what point does the two equations intersect. At what point do the two equations intersect? So we have to find the y coordinate. So in order to do that, all you have to do is choose one of the original equations and substitute in your answer that you have already received. And we've already gotten x equals 4. So you can choose the first equation or the second equation. It doesn't matter. Let's choose the first equation, x minus 2y equals 5. So notice here, we're just rewriting this equation back over, but now we substituted 4 for x. And since we only have one variable, we just solve for that variable. So what would you do? You would subtract 4 from both sides. And then you would divide by a negative 2. And you get negative 1/2. Alright, so the answer is 4 negative 1/2. So this is the point where your two equations, if you graph it on a coordinate system, then this is the point where they will intersect. So let me prove that. Alright, so notice here the purple line represents x minus 2y equals 5. It has that purple box by, and the red line represents 2x plus 2y equals 7. It has the red box by it. So this indicates which line we're dealing with, but what we're mostly concerned about is where do the two lines intersect. And just notice that it intersects where our answer, our solution was. It said 4, -1/2. So it intersects right in here, and this is 4, -1/2. We have some more examples here, number 1 and number 2. So what I suggest you do is go ahead and work number 1 and number 2 out. Pause this video, work them out, see what your answers are, and then in a few seconds I will show you what the answer is, and that will determine if you understand level 1 of solving equations using the elimination method. I'm going to go on to the next level. Consider this system of equations. 6x plus 11y equals -5 and 6x plus 9y equals -3. Now if you wanted to add these two equations together, notice that you do not eliminate any other variables, because you'll get 12x plus 20y equals -8. That is not what we want to do. Nothing cancels out in this situation. We want to eliminate one of these variables, and it's not happening just by adding these two equations together. So this is not how you solve a system of equations. I've seen students do it, just add the two equations together, but you're not solving anything, because you're supposed to end up with x equals a number and y equals a number. So let's look at what we can do. We have a 6x in the first equation and a 6x in the second equation. So if one of these was negative, then the x term would eliminate. So you cannot just stick a negative there. You have to do it legally. In order to do it legally, you would have to multiply one of the equations by -1. So multiply the entire equation, the left side and the right side. So let's do that. So again, -1 times 6x plus 11y equals -5 will turn into -6x minus 11y equals 5 now. Now if we added these two equations together, will the term eliminate? Yes. This -6x plus 6x is 0, so it eliminates. Then let's add -11y plus 9y. We get -2y equals 2. And then what would you do to solve for y? You would divide both sides by -2. And you get y equals -1. But we are not done, because we only got the answer for y. We need the answer for x. So again, this step never changes. You choose one of the equations that you're working with, and you just substitute in that -1. Alright, so this time let's choose the second equation. Again, it does not matter which equation you choose, you're going to get the same answer regardless. So let's plug in a -1 for y. So this is the same equation here, but we're just plugging in a -1. You get 6x plus -9 equals -3. And then what would you do? You would add 9 to both sides, and you get 6x equals 6, divide by 6, and you get x equals 1. Therefore the answer is 1, -1. So let's prove that graphically. Alright, here we go. So it looks like they intersect right around here, and it does look like 1, -1. The coordinate does look like 1, -1. Consider the system x plus 2y equals 6 and 3x plus 3y equals -6. Now again, if we wanted to just add these two equations together, it would not work because no variable eliminates. Therefore, we're going to have to manipulate one of these equations or both in order to eliminate one of the variables. Notice this x and this 3x here. All we really need is a negative 3 and a positive 3 to eliminate. So we need to multiply the first equation by negative 3, and then it will eliminate with the positive 3. But you can't just stick a negative 3 there. You have to multiply the entire equation by negative 3. It becomes negative 3x plus negative 6y equals negative 18. Now, if we added these two equations together, would the x term eliminate? Yes. And we get negative 3y equals negative 24, and then you divide by negative 3 and get y equals 8. So we have y equals 8, but now we need to figure out what x is. So this next step never changes. You choose one of the equations and you substitute that answer 8 into it. So let's try the first equation. Now, normally I try to pick the equation with the less numbers, and as you can see, the first equation has less numbers involved. See that? This equation has 3 numbers. This equation really has like 2 numbers involved. So I always say that's the easier equation, but it really doesn't matter which equation you choose. So let's plug into x plus 2y equals 6. We get x plus 16 equals 6. Subtract 16 and we get x equals negative 10. Alright, again, let's prove that graphically. Alright, so it looks like it intersects way up here somewhere. Alright, here we go. So it intersects right here, and that is negative 10, 8. Okay. So where is that on the y-axis? 8. Where is that on the x-axis? Negative 10. So that the first one, I think you could do. The second one, maybe I need to do the second one. X plus 2y equals 4, and x minus 4y equals 16. Let's try that one. Alright, if we look at these two equations here, if we just added these two equations together, nothing eliminates. You will have 2x minus 2y equals 20. So that's not going to help us at all. How could we eliminate the x's? If just one of these was negative, then we will eliminate the x's. Or, so there are a couple possibilities. You could either multiply negative 1 times one of these equations and the x's will eliminate, but there is a possibility for you to eliminate the y's, because if you multiply this equation by 2, for example, then you will get a positive 4 here and a negative 4, which would cancel. Alright, you probably would think just to multiply one of the equations by a negative, which is fine, so let's do that. Let's multiply equation 2 by negative 1. Alright, so let me rewrite the first equation back over. X plus 2y equals 4. But if we multiply negative 1 times the second equation, we get negative x plus 4y equals negative 16. So just make sure you change all the signs when you distribute. Then let's add together these two will cancel, and we get 6y equals, what's 4 plus a negative 16, negative 12. Then divide both sides by 6, and we get y equals negative 2. So we have the y coordinate. We just need the x. So choose either equation 1 or equation 2. Let's choose number 1. It doesn't matter which equation. So let's choose equation number 1. So we have x plus 2y equals 4, but instead of a y now, I'm going to replace it with our answer over here, negative 2. So we get x, 2 times negative 2, negative 4 or minus 4. We're going to add 4 to both sides. We get x equals 8. Therefore, our answer is, the x goes first, of course, and the y goes secondly. So 8, negative 2 is our answer. So this is option 2. Alright, so we had x plus 2y equals 4 and x minus 4y equals 16. So notice here, this is what I'm concentrating on. How could I have eliminated the y's? Since one is a multiple of the other and one is positive, one is negative already, I could have just multiplied equation 1 by a 2. Okay, so let's see what happens. If we do so, we get 2x plus 4y equals 8. Then we just rewrite x minus 4y equals 16 back over. And notice that the y's will cancel this time. And we have 2x plus x, which is 3x, equals 24. Divide by 3. We get x equals 8 first this time. Then it doesn't matter which equation you choose to plug in that answer. Since I chose number 1 the last time, let's choose equation number 2 this time, just to do it. So equation 2 is x minus 4y equals 16. If you plug in an 8 in the place of x and solve for y, we'll subtract 8, and that becomes negative 4y equals 8, and divide by negative 4, we get y equals negative 2. So was that the answer that we got already? Yes. So I'm just showing you that it does not matter is how you manipulate the equations. As long as you do it legally, your answer should come out. So yes, number 2, the answer was 8, negative 2, and I showed you 2 different ways to work it out. Alright, more complex problems. Consider the system 3x plus 4y equals negative 25 and 2x minus 3y equals 6. Now notice in this situation, if we added these 2 equations together, we will not eliminate any terms. So we need to multiply either one or both of these equations by something in order to eliminate one of these variables. So what would you suggest? Now notice, if this 3 and this 2, they're not multiples of each other. Therefore, we're gonna have to multiply both by something in order to get the same thing. And this 4 and this 3, they're not multiples of each other. So let's multiply the first equation by 2. If we do that, we're gonna get a 6 here. And let's multiply the second equation by negative 3. And if we do that, we get a negative 6. So we end up with the same number, one positive, one negative. That's what we want. Another option would have been to multiply the first equation by 3, and you would have got a 12 here in front of this y, and multiply the second equation by 4, and you would have had that negative 12. So that could have canceled out. But let's go with this first one. If you multiply the first equation by 2 and the next equation by negative 3, you'll get 6x plus 8y equals negative 50, and negative 6x plus 9y equals negative 18. And once you add it together, the x's will cancel out. And you get 17y equals negative 68. Alright, then you would just divide by 17 and get y equals negative 4. Alright, but you're not finished. We're going to substitute y equals negative 4 into one of these equations. Let's do the second equation. Once we do that, we get 2x plus 12 equals 6. Subtract 12 from both sides. We get 2x equals negative 6, and then divide by 2. We get x equals negative 3. So the answer is negative 3, negative 4. Alright, so let's try one of these examples. Alright, what can we do to eliminate the x's? Now, if we wanted to eliminate the x's, what we'll do is multiply this first equation by 3 to get 12, and then multiply the second equation by a negative 4, because we want one to be positive, one to be negative, to cancel out. Or, in order to eliminate the y's, all I have to do is get these two coefficients on the same page. Since this is already a positive 2 here, I can just multiply the first equation by negative 2, and that will eliminate the y's. That's actually less work than multiplying both equations by something. To multiply just the first equation by negative 2 is less work. So that's what I'm going to do. Let's multiply the first equation by negative 2. Doing so, we get negative 8x, negative 2y equals negative 18. And I'm going to rewrite 3x plus 2y equals 8. And then add the two equations together. Now here, the y's is what we wanted to eliminate, and they did. Okay. So we have negative 8x plus 3y is negative 5x equals negative 10. Divide by negative 5. We get x equals 2. Then we're going to choose either the first equation or second equation. I want to choose the first equation. Alright. 4x plus y equals 9. And I'm going to substitute in 2 for my x, since that's my answer. Get 8 plus y equals 9. Subtract 8. We get y equals 1. So the answer is 2, 1. Alright, and